Hey there. Okay, earlier this week we learned how to solve a system of linear equations by graphing, and where the lines intersected was the solution. Now we are going to talk about a system of linear inequalities, okay? Slightly different, okay, but you approach it the same way. So a system of linear inequalities is two or more linear inequalities. Remember, a system is two or more. Okay. The solution to the system, it's not an individual single answer. Okay, that's how this is different. It's actually a region of solutions. Okay. So it is a region of solutions that satisfy both inequalities. It's a region. Okay? So for instance here, we've got these lines graphed, and where it is shaded is where it comes together. So your solutions are found in the shaded region. So your solutions would be here. Any ordered pair here would be a solution to the system. And it's more than one. It's infinitely many. Okay? Also keep in mind, just a reminder from the week before, solid lines and dotted lines. If you have solid lines, then the line does not contain the solutions. If you have, did I say solid? If you have dotted lines. If you have solid lines, then the solid lines are solutions to the system. So for instance, that point would be a solution to the system because it's on the shaded region and on a solid line. Okay? Same thing, anything along these solid lines right here would be solutions. So let's go ahead and record just a couple of ordered pairs that would be a solution to this system. Like this one would be 1, so that'd be -1, 1, 2, 3, 4. So like -1, 4 is a solution to this system of inequalities. Again, something on a solid line next to the shading would be a solution. So 1, 2, 3, 4, 1, 2. So 4, 2 would also be a solution. And there's many, many more. Okay? So steps: graph one inequality and shade it. Graph the other inequality and shade it. And the region where the shading overlaps, is a solution. Okay, so what you might want to do is pause the video and maybe get 2 different color highlighters. Okay, and I would make sure you don't get anything dark. I would get like some yellow, orange, maybe some pink. Okay, so have you 2 of those, and also a straight edge. So let's get started. Okay, these are in slope-intercept form, so really easy to graph. So we've got a y-intercept of -3 and a slope of 4, and we can make that 4 over 1. So we're going to rise 4 and run 1 from my y-intercept. Rise 4 and run 1. Okay, now let's go back and remember from the other week, solid line or dotted line here. Well, it's going to be a dotted line or a dashed line because there is no equal to bar. Okay, so I'm going to draw this with a dashed or dotted line, and I'm going to be very precise here. Okay, and now we need to shade. So I'm going to pick one of my color highlighters here. And this is greater than. Remember, if you read from the left, you get to the big open spot first. This is greater than. So we are going to shade above this line where the y values are bigger. So think about it. Right here's where the line is. Up here, the y values are bigger. Down here, the y values are smaller. So we're shading on this side of the line. So let's just get us a highlighter. And we can shade all of this. We're going to do a little coloring today. All right. Let's do the other one. Y-intercept is 1. Slope is -2, so we're going to go down 2, right 1. Down 2, right 1. And it's greater than, and we have an equal to bar, so this is a solid line. This is a solid line. Let's be very precise here. Okay, now you got to stay focused on what line you did here. Don't get it confused with the other line. Okay, greater than means I'm going to shade above this line, and let's talk about that. Well, right here is where the line crosses the y-axis. These are the y values that are greater than. These are the y values that are less than. So I am going to shade on this side of the line. Okay, so I'm going to get me a different color highlighter. I'm going to follow this new line. And color this in. Okay, now, just so you know, this whole picture is not the answer. We have not really designated the answer yet. The answer is where the shading overlaps. Okay, so where is the overlap at? Well, it's right in here, and I'm just going to grab pencil or pen so that I can distinguish this for you. Okay, so the solutions are here. Not here, not here, they're here. So this is where the solutions lie. Okay, now, got to be careful. Okay, on this solid line here, these are solutions. On this dotted line, these are not solutions. And where the dotted line and the solid line come together, whatever that point may be, that is not a solution because one of the lines is dotted. Okay, so let's just record some of our solutions here. Let's see. Over 1, up 1, 2, 3 would be a solution. Over 1, up 3 would be a solution. That means it satisfies both equations, this ordered pair. Let's see. 0, 1 is a solution because it's on the solid line next to the shading. Okay. 1, 1 is not a solution. 1, 1 is not a solution because it's on a dotted line. So hopefully that kind of explains everything. All right, let's do this fella. Okay, first of all, hopefully you remember that if we only have an x, that is our friend Vux, and that is a vertical line. If you only have an x in the equation, that is our friend Vux, that is a vertical line. If you just had a y, that would be a horizontal line. So I need a vertical line at 3, and it's going to be a solid line. So x equals 3, 1, 2, 3, and I am going to make a solid vertical line here. Okay, we need to shade. This is less than, so think about your x values. We want where the x values are less than. Well, here's where the line crosses. Here's where the x values are less than, so I am shading on this side of the line. Okay, so I'm going to grab me a color here. Right. Okay. Here we have a y-intercept of -3. And we are going to rise 1 and run 2. Okay. We have an equal to bar here, so that's a solid line. Okay, and let's just keep focus on that line. This is greater than, so I am going to shade above this line. I'm going to get me another color. Let's try green. Let's see if we'll make blue here. So I'm going to shade above this line. So I'm just going to follow this line a little here. Okay. Now, so where is the region where all my solutions lie? Well, the overlapping starts over here, down here, and it's all of this. So the region where I shaded with my pen is where the solutions are. Okay. So let's talk a little bit more. All of these ordered pairs are solutions to the system. Since this is a solid line, anything along this solid line down to here is a solution to the system. Anything on this solid line is a solution to the system. So let's list a few of these. Let's just pick some points like this one. That's -2, 2 is a solution. Okay. Somewhere on this line, this is 1, 2, 3, 0 is a solution because it's on the solid line next to the shaded region. Okay. Down here, these are solutions. This is the ordered pair -3, -2. And there's many more. Okie dokie. All right. Skipping around a little bit. Let's just take a look at this. They give you the system of inequalities, and they're asking you, is the point -2, 4 a solution? Well, let's find that point. -2, 1, 2, 3, 4. It is outside the overlapping of the shading, so it is not a solution. Okay, so let's flip over on the back. I just want to do a few of these. Let's just do a few of these. Okay, so 1, 2, and 3 are asking you, they are actually giving you the system, and they're asking you if these ordered pairs are solutions. So you can pause the video and let's do 1, 2, and 3, and then we'll look and see what your answers are. Okay. So number 1, 0, 0 falls on the solid line next to the shaded region. It is a solution to the system. Here, the point -1, -3 falls in the shaded area. It is a solution to the system. I did graph the other 3 so you could see where they're at. Okay, they're not in the overlapped region. Okay, and -2, 4 is here. It is not a solution. Okay. Okay, I want to graph one more because I want to bring up the golden rule for inequality. So I want to graph one more of these, okay? Okay, so when we are in standard form with inequalities, we can still do x and y intercepts, but we have to be very careful, okay? Here's where we're going to have to be careful. So let's go ahead and do this. If I cover up my x, my y-intercept is -4. Okay. If I cover up the y and I divide by 2, my x-intercept is -2. Okay. I'm going to get a dotted line. Okay. And this is greater than, so I'm going to shade above. Okay. All right, this little guy, let's cover up the y. And if I do, my x-intercept is 4. Okay. Cover up the x. If I divide both sides by -2, my y-intercept is -2. Okay. It gets a solid line because there's an equal to bar. Okay, now, this is why I wanted to do this problem. If you remember what we talked about, the golden rule is if I end up having to divide by a negative number, the inequality symbol switches direction. So what I'm going to do is I'm going to show you this by converting this to slope-intercept form. So remember, slope-intercept form is when y is by itself. So I'm going to subtract x on both sides. And I get -2y is less than or equal to -x plus 4. All I did was write those. And right here's where it happens. It happens where the y is, not where the x is. It happens where the y is. I am going to end up, to solve for y, I am going to have to divide by a negative number on both sides. So the inequality symbol actually switches direction. It switches direction from less than to greater than. So you have to be very careful when you're in standard form. If that y is negative, that inequality symbol is going to switch directions. And I can finish this on up. This is 1/2 x minus 2. But the point here is because I divided both sides by a negative number, my inequality is actually greater than. Okay? So we're on this line, and I need greater than. And these colors worked out well. I like these colors. Notice, perfect. Where I did a yellow and a pink, and where the overlap is turned orange. So that's awesome. So the orange area is where my solutions are. And along the dotted line, those would not be solutions. Along the solid line, those would be solutions. Okie dokie. Y'all have a good one.